In this video we will see the moment of inertia of C-section. So numerical, determine the moment of inertia of the C-section shown in figure about its centroidal axis XX and YY. This is the figure. Total height of this C-section is 200 mm and width is 100 mm. So upper flange height is 20 mm, web thickness is 20 mm and lower flange height is 20 mm. Now here asked about the centroidal axis XX and YY moment of inertia. So we have to find here the first centroid of this C section and then mark the centroidal XX axis and centroidal YY axis. So first X bar and Y bar is nothing but the centroid of this C section. Then how to find this? Is summation of XA divided by summation of A. So you can refer my previous video how to find the X bar and Y bar. Then in another way, X bar is find here the just C section is divided in three parts, that is area A1, A2 and A3, and then you have to add these areas and distances. So X bar is equals to A1 x1 plus A2 x2 plus A3 x3 divided by A1 plus A2 plus A3. Here A1, A2, A3 are the area. Then Y bar is summation of YA divided by summation of A. In another way, Y bar is find A1 Y1 plus A2 Y2 plus A3 Y3 divided by A1 plus A2 plus A3. This is a summation of area. This is the C section. We find here the X bar and Y bar. So for that we have to prepare here the table. In that table just we find here the X1, X2, X3 and Y1, Y2, Y3 distances, then take the multiplication of this XA and addition of these total areas A1 plus A2 plus A3. So this is a C section. So for that we prepare the table. In first column serial number, second column area, then in third column that is X bar distance for particular section or area, then Y bar distance, then multiplication of X into A, Y into A. So you can see in the figure, just divide this with the dotted red line. This is the A1 area. Then take the area, this 100 mm length of this and height is 20 mm. So this is a 2000 mm square. Then second area. So divide this second area at the upper flange. This is the dotted red line. This is A2 area. This A2 is height is 160 and width is or web thickness is 20 mm. So this is a 3200 mm square. Then third area is A3 100 mm length and height is 20 mm. This is 2000 mm square. Then take the X bar. Then X bar is we have to find for the each section A1, A2, A3 centroid of this section. So this is the centroid of this section, first section, that is G1, and we have to find the X bar X1 distance. So X1 distance we have to find from the left edge. So this is the X1, you can see in the diagram X1, and X1 is what? This is a total is 100 mm, 100 divided by 2, that is 50 mm X1. Similarly for the A2, first mark the centroid of this G2 and then take the distance X2 from the left edge, that is 10 mm. Total web thickness is 20 divided by 2, that is 10 mm. Then next one is the third area. This is a G3 of the centroid of this area, and this X3 distance from left edge, that is 50 mm. Total is 100 divided by 2, 50. Similarly Y bar, take the vertical distances. So first is Y1 up to the G1 centroid. This Y1 is what? 20 divided by 2, 10 mm. Then Y2 is from lower edge to the G2. G2 is centroid of second area, that is 100 mm. Total is 200 divided by 2, that is 100 mm. Then third one is Y3. Y3 is from lower edge. This is 20 plus 160 plus 20 by 2, that is 190 mm. Then take the multiplication of this A1 into X, that is 1 into 10 raised to 5. Then A2 into X or X2, that is 32,000. Then A3 into X3, that is 1 into 10 raised to 5. Similarly, take the multiplication of y into or y1 into a1, a2 y2 into a2, y3 into a3. These are the multiplication. This is 2 into 10 raised to 4, 3.2 into 10 raised to 5, and 3.8 into 10 raised to 5. So in this way, first calculate all these values and then take the addition of this a1 plus a2 plus a3. This is the 7,200. Then take the addition of x into a for all values. This is a 2.32 into 10 raised to 5. Similarly, take the addition of y into a. This is 7.2 into 10 raised to 5. So after getting all these values, mark the x bar and y bar in the diagram. So first just put all values in the equation. X bar, that is a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. So put all values a1 a2 a3 and take the division of this, that is 32.22 mm. This is the x bar. So mark this x bar from the left edge. Then this is a 32.2. You can see in the diagram. Then y bar is y into a or y1 a1 y1 a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. Put all values, take the addition or simplify it and take the division. There it is 100 mm. So you can see in the diagram, this is x bar and y bar is marked here. And related to the x bar and y bar, just draw one horizontal line through this centroid. This is a xx centroidal axis, and draw one vertical line related to this y distances. This is a yy centroidal axis. So we have to find here exactly the xx and yy centroidal axis moment of inertia. So next step is we go for the centroidal axis moment of inertia. So first we have to find here the centroidal axis xx moment of inertia. So for that, remember here, to calculate the centroidal x axis moment of inertia, take the y distances and centroidal axis y moment of inertia, then take the x distances. Remember this one. So first here the xx ixx total moment of inertia of this section, divide into 3 parts. This is a1 a2 a3 areas, and take the moment of inertia of each section, that is ixx1 plus ixx2 plus ixx3. So here all are in standard shape, a1 a2 a3. If you see there, then it is a rectangle. So rectangle, we can calculate the moment of inertia standard, that is bd cube by 12. So before that, we have to apply here the parallel axis theorem. So you can refer my previous video, parallel axis theorem. So here apply the parallel axis theorem for each section. Ixs is equals to, for first section, Ig1 plus A1 yc square plus Ig2 plus A2 yc square plus Ig3 plus A3 yc square. Okay, Ig1 is the moment of inertia of first section about its own axis, and then Ig2, Ig3, and A1, A2, A3 are the areas, and yc square we will see here, the yc square how to find here for each section. So first section A1 moment of inertia, it is a rectangle bd cube by 12 plus A1. Now first yc square, that is take this minus y bar minus y1, y bar minus y2, y bar minus y3. You can see in the formula, that is y bar minus y1 first distance yc square bracket square plus again A2 is the rectangle bd cube by 12 plus A2 into y bar minus y2 bracket square plus bd cube by 12 plus A3 into y bar minus y3 bracket square. So put all values. For first section, B is 100 into height is 20 cube divided by 12 plus area 2000 into y bar is 100 minus 10 bracket square plus B for second section 20 into 160 cube, height is there, divided by 12 plus 3200 into 100 is the y bar minus y2 is 100 again bracket square plus 100 into 20 cube divided by 12 plus 2000 is the area A3. into 100 y bar minus y3 is 190 bracket square. So after simplify, we will get the Ixx moment of inertia, that is 3.93 into 10 raised to 7 mm raised to 4. This is the centroidal x-axis axis moment of inertia. Now we'll move towards the Iyy, that is centroidal y-axis moment of inertia. So here, whenever you take the moment of inertia about the centroidal y-axis, then take the x distance. Okay, x bar minus x1, x bar minus x2, and x bar minus x3. All procedure is similar to the Ixx1. Instead of only here the values is changed. B for the first section is changed, then second section change, and third section is changed. Okay, so we will see here the Iyy1 plus Iyy2 plus Iyy3. Each section moment of inertia. Then apply the parallel axis theorem. Ig1 plus a1 yc square plus Ig2 plus a2 yc square plus Ig3 plus a3 yc square. Okay, so Ig1 for the first section is bd cube by 12 plus a1. Here yc square distance is x bar minus x1 bracket square plus second section bd cube by 12 plus a2. Now here x bar minus x2 bracket square for second yc square plus third Ig3 is bd cube by 12 plus a3 into x bar minus x3 bracket square. So put here the all values. B for first section is 20. Okay, in line with the this x distance, that is 20 into 100 cube divided by 12 plus 2000 is the area into 32.22 minus 50. Okay, x1, x bar minus x1 bracket square plus 160. Okay, B for second section 160 into depth is 20 cube divided by 12 plus 3200 into 32.22 x bar minus x2 10 bracket square plus 20 B. Okay, third section B is 20 into 100 cube divided by 12 plus area is A3 2000 into x bar is 32.22 minus x3 is 50. Okay, bracket square. So after simplification, we'll get the Iyy 6.28 into 10 raised to 6 mm raised to 4. Okay, so in this way you can calculate the for any C section moment of inertia about the centroidal x-axis and centroidal y-axis. Okay, thanks for watching.